Let's take a look at a topic. For example, at this time in this network, I got an admin address. That is, an address segment is given. Address range. Let's say 194.2.3.0. Such a network segment. 24-bit mask. Now it's time to assign it to 4 departments. These 4 departments are different departments. Then I want them to belong to different address segments. Now we have to do an address division. Assign to 4 different departments. The first is the project department. Suppose there are 58 people in the project department. So for these 58 people, we're going to assign it an address accordingly. The next one is the RAND department. More people in RAND department. 100 people. The address is something we'll fill in a moment. Next is the marketing department. The marketing department assumes 27 people. There's something called a gateway involved. Since we haven't gotten there yet. So when I talk today, I won't count this address. But I have to design the question. I'm going to design it. Okay. Suppose there are 15 people in the finance department. We're going to make a division. As a web worker, now you have to plan an address segment. First, I'll teach you what to do when you're doing something like this. In fact, in the future when really planning the project, by default some subnet masks are used. Mask calculator can calculate. But let's follow normal way of planning. When you do address planning, planning must be made for the department with the largest number of people. That is, find a maximum value. It must be ensured that a subnet is now sought first. Is now a Class C address segment. Make sure to ask for a subnet first. And this subnet is okay. Satisfy the situation with the largest number of addresses. Now there are 100 people in the RAND department. Therefore, it must be allocated to the RAND department first. Otherwise, after planning the address, divide it into different small subnets. Eventually you will find 100 people in the RAND department can't fit in. This will not work. It's like you are cooking for others in the cafeteria. If you want to make sure everyone is fed, then you should let the big eaters come first. Small eaters in the back. It has some headroom. If you let the big eaters come later, that might be their turn. Leftovers are not enough. So, this address segment itself must be planned. Just put. Sure is reasonable. Must be allocated. But if these departments with a small number of people are allocated first, it is very easy to cause too much stuff allocated to them. Make sure. Assign to the person with the most number first. Satisfy the situation with the largest number of addresses, or the most seen. Once the address is assigned, can no longer be used by others. Notice. Can no longer be used by others. A network segment. If I assign it to the RAND department, I can no longer use it for other people. Because we have to isolate different network segments. Like you cut a cake. After you cut it, give it to someone else. You can't say, others seem to have some left over. I have to come back and share it with another person. This is not possible. That's for us on the project. That doesn't meet the current overall requirements. Cannot be in a network segment. If there are a few addresses left in the network segment, I can still use it for you. It doesn't make sense to divide the network segment. So once the address is assigned, can no longer be used by others. So let's solve this problem now. We now need to know what the addressable addresses are. Distribution has not started yet. Then the address that can be allocated. Must be the most. Is 194.2.3.0. 24-bit mask. We first give the RAND department. Because there are too many people. In the RAND department. RAND department is 100 people. If a department has 100 people, then the default subnet. To satisfy 100 people. So how can you be satisfied? This requires more addresses. Need more than or equal to 100 addresses. Can you understand? Since now every variable bit are 2 cases, then it is 2 to the power of x. Please pay attention. 2x squares are fine by themselves. But you have to consider. Now it's time to calculate. Each network segment has 2 addresses. Network address and broadcast address. So it is equivalent to need. Subtract these 2 addresses. X stands for variable. That is to calculate. How many host bits are there now? How many network bits? But after subtracting these 2 addresses, must be greater than or equal to 100. I want to emphasize to you. We'll learn something later. Gateway. By default. When we go to assign addresses to enterprises, you have to take into account the problem of assigning a gateway to each network segment. Since we haven't learned about cross-segment, there is no problem with subtracting 2. After subtracting 2, the address is now available, but only to ensure that the internet can communicate with each other. In the future, once we are going to access the extranet, or access across network segments, must have a gateway address. As for the gateway, we haven't talked yet. So even if it is -2, even if you subtract 3 here, plus the gateway can also be used together. I'm just giving you an introduction. Okay. Let's start by subtracting 2. This x is what we call the host bit. 100 people are 100 hosts. That x is actually the host bit. So let's calculate what x is. Logically speaking. Before subnetting now. The host bits are 8 bits in total. Address that can be assigned at this time. Is such an address. Okay. Is 7. But everyone will find. If it is 2 to the 7th power. It's more than 100. The rest of the address is wasted. Please pay attention. We use this method when calculating. Often it is not possible to do a tight fit. Not exactly calculated. So, it is normal for us to set aside multiple addresses. So now 7 host bits are actually used. That means network bits need to be borrowed. It turns out that the network bits are 24 bits. Borrow 1 now. At this time. Since I've borrowed. Subnetting for sure. Divide into 2 subnets. I'll just tell you one of the above. The first one is 194.2.3.0. Don't look before. Just look at the one behind. Originally this bit was 0. Now divide 1 more. Then this one is 1. This is the one who borrowed. Then for the subnet. Except for the one you borrowed. The last 7 bits are the host bits. All set to 0. This is what is calculated now. The above calculation should be 0.0. This one below is 0.128. That is 194.2.3.0. Mask is 25 bits. We're taking a borrow now. After borrowing,